as we started Achieving Cures together, 2015, we were talking about doing fecal transplants and studying fecal transplants. People looked at me like I was an alien. It's kind of like what? You're doing what? And now it's come so far. I think there was even a South Park episode on fecal transplants. Once it's on South Park, it's mainstream. So, Alex, would you walk us through what is FMT and what it does?
Well, okay, so originally how it came to be was patients with C. diff infections. It's just a brief lesson in anatomy and physiology, the way the digestive tract is put together in humans. You eat your food, gets through the esophagus, gets in the stomach. Then there is small intestine. That's the longest part of your digestive system. That's where most of the digestion happens and nutrients get absorbed. And about 5 to 10% of nutrients are still not digested. They enter the colon. That's the last part of the digestive system. And that's where you have microbial fermentation. Things really slow down there. And it takes 24 or maybe even a couple days transit. It gives the time for microbes to finish that process. We actually get about some calories from that as well, but you can live without a colon. It's dispensable, at least in humans. Humans have the smallest part of that microbial organ of any mammal. It's because we learned how to cook food, and that makes it easier to digest. But, our cousins like gorillas, they depend on that microbial fermentation for 65% of their calories. That's why you have them, if you observe them, they're just sitting around munching on grass and make a lot of fart noises, and they don't have much to do besides that. They can't expend much energy. That's why their brains are smaller. Once we learned to cook food, then we had more time to roam around and think about things. And anyway, so bottom line though, all mammals, all animals have this symbiosis with microbes one way or another. And when we use antibiotics, we throw a grenade in there. And people have gotten away with that for about 100 years, and it's catching up with us. So this particular infection takes advantage of the disruption of microbial community with C. difficile. Once you pick it up, they make toxins, they cause inflammation. That helps the microbe to actually get out. It gets out in a way of spores so that it can infect somebody else. That's its life cycle. And we treat that with antibiotics, but we can't completely kill it because it makes spores. And so it can go into these cycles. And with cycles of treatment, we really decimate the microbiome. That's the original condition. For that, all you need to do in most patients is just one inoculum of healthy stool. Doesn't matter whose stool. It will work 90% of the time. And with whatever modifications, we can get it up to 98%. That was the original idea, just a simple repair of microbial community structure just to resist that infection. Most other conditions is not quite like that. The microbiome is not decimated. In fact, it's quite entrenched into that particular host. And that's why you need to give this enema treatment or whatever treatment, however the route is, multiple times to try to really force a new microbial structure. That's what we think one of the mechanisms is. They've made in the movie an observation, which is certainly true, that it's a lot more intricate as to what exactly is the mechanism, let's say, for ulcerative colitis. So when we designed this trial that your son participated in, we had a hypothesis of what kind of microbial composition we wanted. So there was some rational selection of donors based on sulfur metabolism, for what it's worth. I don't know how many steps we're going to need to do for different diseases to really sort out how to rationally design the therapeutic. Whether it's going to be a year or 1,000 years, because it is so complex. There's hundreds of different species. And then you're talking about immune system, which is complex itself. And then if you're looking at autism, then you're talking at the nervous system and the brain, which is complex, and you have to figure out all these mechanisms. So we're trying to make those steps and move this field forward. But it depends on each individual disease is probably a different answer. I just thought there was another reason why I like the name. You know, my wife is a fashion designer, and I work with shit. So it's perfectly put together.